Awesome. Thank you, Chaz. So again, without further ado, I'm Miles Owens, and we're going to be talking. This is the suspension preliminary design review. I'm the subsystem lead, and let's get straight into it. So first, if you came to the overall subsystem PDR that happened a couple weeks ago. One of the main, high-level customer goals that we have as a team this year is to improve serviceability and manufacturability of the car. So kind of throughout both, all three, my aspects of the design, Gio's aspects of the design, Kalen's aspects of the design, we're all going to be trying to sort of progress towards, a more serviceable and adaptable, subsystem as a whole. So all of our design choices are ideally trying to, reflect that overall goal. To talk about some of the requirement specifications. I won't dive too deep into this, but I'll just cover for a bit. The first is that the system must be, rapidly tunable and adaptable to every event at Baja SE competitions. And to sort of give some context to what that means to us is that, like, here up on the right, there's like basically a configuration. Like one of the things we've done recently as a team, which I'll talk about, later, is that we've sort of started to, keep track and like nail down on some like keeping track of basically the configurations that we're running as a team in, all the dynamic events and in different, conditions for the car. And we think that, having a really, really ironed out set of configurations that have, data backing certain, design, certain, settings for the car, like tire pressure, shock compression and rebound setting, coil over preload and ride height, then that's going to overall contribute to, a significantly more robust model for serviceability and adaptability as a team. Additionally, so again, the system must be serviceable and have increased manufacturability compared to previous YGR vehicles. That's going to be a pretty low-hanging fruit, given that, in the past, at least coming, into this role, there hasn't been a lot of work done to specifically identify, settings and, specific design choices that, are geared towards serviceability and manufacturability. Some of the specifications which I'll kind of run through quickly are that the system must weigh less than 120 pounds. That's entirely set based off of the previous year's car, even though the weight limit wasn't necessarily, a serious point of design improvement for this specific model of car. I just set that to basically the previous model so that we don't, go over the weight limit or increase the weight of the car. The track width must be, less than 64 inches, and the wheelbase will be less than 57 inches. The track width is obviously set by the Baja SE, competition coordinators, but the wheelbase is something I can talk about later as a possible design choice or design change that we'll probably be making, over the next couple months with the design of the new suspension. Then we identified that there must be, an adjustable ground clearance between 7 and 14 inches. One of the primary failure modes that we were kind of seeing, in recent years, especially in this past year, is interference. So in addition to just, all out, mechanical failures of parts, one of the main reasons that parts fail for us is because of interference, either with other parts in the car, so with other subsystems like drivetrain, or purely with just hitting the ground, or like, the car running into an obstacle underneath the ground because there's a ground clearance that's not satisfactory enough for the dynamic event at hand. So an adjustable ground clearance would allow us to, both, have a bunch of adaptability for different dynamic events, because some of the dynamic events are going to benefit from having lower ground clearance, and some are going to benefit from having higher ground clearance. A maximum half shaft plunge of 1 inch was also identified to be a pretty important requirement, especially with the issues that we had a couple years ago with half shafts falling out of the differential and other components of the car. And then finally, the camber change, toe change, were set to be 8 inches and 1 inch, or under 8 inches and under 1 inches, respectively, over the range of motion of the suspension, not including the steering. And those were defined, which I can talk about later again, from some of the analysis that we've done in CAD with respect to kinematic and dynamic models of the suspension from last year's car. So here again is some more background kind of on where the suspension is at currently. To preface this, the suspension kind of has the robustness has significantly improved over the past year. During the Arizona competition, the primary failure mode we were seeing was with our trailing arm, which is what I'll talk about in a couple slides when we get to the CAD portion of this part of the presentation. But in Arizona, we only had pretty much a single suspension failure that was in one of the front arms, which, like I said, was kind of caused by an interference related issue. So the competition performance is now not necessarily only limited by the performance of the suspension as far as it relates to not failing, but it's also, starting to be a problem of our team needing to be really, really efficient when it comes to servicing the car when the car is not on the track. Um, some of the observations that we have are, like I said, there's kind of two modes of failures. We're seeing structure failures and interference failures. So, for example, structural failures, the wishbone at the Baja IC Carolina competition, the lower A-arm, failed just after a significant amount of fatigue over a number of endurance laps. The uprights and trailing arms have also experienced failures, or not all out, mechanical failures, but some mechanical deformation over the course of the endurance events and other dynamic events and throughout testing. And also interference failures, like I said, ground clearance and steering angle are two things that kind of really are limiting our team as far as it relates to interference-related failures. And improving the ground clearance or increasing it, and also increasing the steering angle, or we've identified would probably lead to significantly more adaptable or possible adaptable setups that the car can have. So increasing range of motion is bottlenecked by those interferences of the current design. And finally, also the cost. So the suspension currently is quite expensive. The shocks are quite expensive, and additionally, like a lot of the stock material we use is relatively expensive. So like there's a lot of resources that get poured into the CNC uprights that we have right now. So it's a lot of time spent on the CNC machine, and also just a lot of money for the team financially. And many spares are required also generally with the current suspension setup. So these are just kind of observations that we have going into that I have going into the design of the new suspension. So to talk about some of the approaches that I'm taking for design, manufacturing, and testing. Firstly, one of the new design choices that I'm thinking about is shortening the wheelbase of the car. We've done some basic analysis of how that will affect the steering angle, because that's one of the things that's going to improve our adaptability as it relates to the maneuverability in S&T events. Additionally, lower frame shock mounting points. Again, when we get to the CAD, I can kind of show you more in depth what that might entail. But right now, the rear ride height of the car is limited by the shock mounting points on the frame, and changing that is one design decision that we're considering making for the next year's car. For serviceability, one of the design or gearing towards serviceability, one of the design choices that we're thinking about making too is standardizing fasteners and ball joints. Right now, there's a discrepancy between the ball joints that we use. At least there's different sizes. That's what I mean. So standardizing the size of ball joints that we have that we use in the suspension, and also just the size of all the bolts that we have, could lead to significantly faster servicing times, which we have tried to kind of record in the past, or just over the past year. But we think that that a design decision of making all the fasteners and ball joints standardized would significantly improve our serviceability. To talk about a bit about the manufacturing, like I said, some of the present manufacturing methods that we have are relatively costly in terms of time and just pure financial aspects. So some of the new parts that we have, the goal is to have a clear plan for manufacturing time and cost. One of the main ways that we're kind of going about designing around this is changing the uprights to be aluminum from aluminum to be steel. And we can again talk about more like what that might mean later. And we can talk about the design that we currently have. And finally, for testing, the goal is to perform tests that give us insight on parameters that we have control over. So one, the design of the components, and then two, the actual tuning parameters used. And also the goal is to focus on full vehicle testing. In the design presentations that we've had over the past two competitions, so at Arizona and in South Carolina, there's sort of been a lack of full vehicle testing, which would support other areas of the car too. And the team definitely will benefit from more full vehicle testing this year. And we want to perform tests that quantify how serviceable the system is. So we can make design decisions like changing standardizing the fasteners and ball joints, and decreasing the total number of parts, but we also want to have like hard data that shows exactly how much for performance increase that gives the team. So this is the kind of the current model that we have of the car. As you can see, there's a trailing arm suspension in the rear, and a double wishbone suspension in the front. And that we are still using the AFCO 63 series 8-inch shocks in both the front and the rear. Some of the major design decisions that changed from last year were modular 6061 aluminum rear uprights. So if you can see in the rear, the trailing arm is separated into two pieces, one CNC aluminum part and one 4130 basically tube and flange assembly. that uh, did increase serviceability between the last model of the car and this model of the car. There's also for both the front and the rear, we switched the bearings from being a single dual deep groove ball bearing to being individual deep groove upright like bearings, which has significantly decreased the cost and increased the serviceability of the car too. So yeah, we can come back and kind of talk about this later, but again, all this is designed in Siemens NX, and all the analysis we do is in SimCenter 3D in NX. Some which I can talk about now. Some of the complete analysis that we've done has been, basic line model dynamic simulations for the front and the rear suspension independently of each other. And additionally, all of the significant load-bearing components, which is inclusive of the trailing arms, the front uprights, the upper arms, and the lower arms, undergo front, side, and drop impact load cases through finite element analysis. But some of the analysis simulations that we currently think would be, most useful for the team as it relates to the design of suspension and steering and brakes too, is a full vehicle dynamics model, which would allow us to generally refine the load cases that we have, possibly the inclusion of knockdown factors in welding analyses. So having some sort of collaboration with a welding team to determine what a knockdown factor would look like for different types of welds that would be, included, especially with the design of the new front metal uprights that we're making, which will have a lot of welds in them. And then finally, because we're switching a lot of parts to be from aluminum to be steel, there's also an argument that a fatigue analysis would be useful because of the endurance limit that we will have inherently on those steel parts. To talk a little bit about the testing that we've completed and will eventually need, this was mentioned in Benzier's presentation yesterday about the frame, but we've done a lot of drop testing over the last year, where we've collected a variety of data, including strain data, acceleration data from video analysis, and acceleration data from high fidelity Siemens accelerometers. So that's been completed both in dynamic situations, so like when the car is driving over a jump and the wheels are turning and the car is translating, and in more static scenarios where the car is just dropping on the ground in place. In addition to that, we did a lot of testing over the summer with different trailing arms. We saw multiple failures with the trailing arms at the Baja City, Arizona competition, and there was a lot of reasoning to do trailing arm experimentation over the summer. So we did a lot of prototyping and testing of trailing arms over the summer. However, some of the needed testing that we're looking to complete over the next couple months is on-track testing, on-track dynamic testing with the wheel force transducer, which will give us, anywhere between 3 and 6 degrees of freedom of force data on the wheels, which will be massively helpful for refining the load cases that we have and designing more, efficient parts. Similarly, on-track dynamic testing with strain gauges. This is something we almost got to last semester, but didn't quite have the data acquisition capabilities to do so at the time. And that would provide us similar data to what the wheel force transducer might give us as it relates to load cases. And finally, to kind of tie this back to the adaptability point kind of from earlier in the presentation, doing some sort of tuning setup experiment with a design of experiments of different settings from that the suspension can have would give us direct performance change data with a variety of tuning setups. So the idea would be we run an experiment with a bunch of different tuning setups in a specific scenario, even if it's just like acceleration or braking, to get a better idea of what an optimal or an optimized tuning setup will be for the car. Finally, to talk about like the highlights kind of that we're looking to maybe discuss later. First of all, certain components of the suspension could benefit from more in-depth analyses, but we're currently limited by our knowledges of the load cases, which is again why kind of like the testing we have is geared towards finding load cases with like the wheel force transducer and dynamic strain gauge modeling. And the question that we kind of have would be like, would prioritizing subsystem level modeling be more valuable than the in-depth analyses of individual components like fatigue analysis? Additionally, the welded uprights that you can kind of see up on the top right of the screen here have the potential to save us time and money, but the verification of the manufacturing processes and repeatability may become a problem down the road. So I'm curious to hear anyone's thoughts on if welded uprights have been tried on the team in the past, or what any possible challenges we might run into with a design that uses a lot of welds for something like the uprights. Additionally, measuring serviceability is something that our team has not done directly, and I'm kind of curious personally as to how serviceability and manufacturability is quantified in industry. And I'm curious as to if there are ways that we could kind of apply um, methods that are used in industry to serviceability and manufacturability testing as a team in Baja. And finally, I would kind of open it up to any suspension design challenges the team has run into the past, along with any solutions that might have come up for those challenges. So those are kind of the highlights I have. Again, we're going to save questions until the end, but right now we're going to switch gears to Kaylin, who's going to talk about the steering design currently. So I'll hand my computer over to her, and she can take it away.
No, thanks. Good evening. My name is Linquit or Kaylin. I'm the steering team lead for this year. So as for our goals, our high-level goal is also to be serviceable and tunable or adaptable. And our specifications are there's a weight specification, which is a cascading requirement from our vehicle level requirements. We want to have no interference with the suspension system, specifically the upper A-arms, which is a problem that we've had in the past. Because of the restraints on the driver, we want to have butterfly steering, which is to say that lock-to-lock steering is 180 degrees, and the drivers won't have to do like hand-over-hand steering in order to turn the car all the way. We also want steering link adjustment of plus or minus 1 inch, which will allow us to change static toe and camber. Another goal is also to have an outer turning radius of 11 feet. And the limiting factor so far for us has been the interference with the drivetrain subsystem. So if we turn the wheel too much, then the half shafts lock up and we can't transmit power to the front wheels, which is something that we are working to fix this year. So a bit of a background on the steering. Our previous car, we ran a reverse Ackermann steering geometry, and then for this current car, we switched over to a parallel steering. And this change was motivated by the need to reduce bump steer and cambered gain over the range of motion. And also it was to eliminate the use of U-joints in the subsystem, which made it a lot more simple, but it also limits where we are, since the steering column is just a straight tube now, it limits where we can put the steering housing. Our steering radius is improved significantly, but at the last competition that we went to in South Carolina, it still wasn't enough to complete the maneuverability track, which was objectively a pretty hard track, but it showed us that there was still a lot of room for improvement in the steering radius, as well as the packaging. And something that the judges mentioned was that in our design presentation, our analysis didn't account for like force feedback from tires and like force inputs on the system, which we want to change. So my approach to this is, since we are, as Benzier may have mentioned in her PDR, we're cutting a few tubes off the footbox of the car, which will give us the chance to make changes to the steering system. So I want to, since we're also making new uprights, I want to experiment with a few different steering geometries. This year we are planning to go towards a more Ackermann steering. I'm working to develop a dynamic model for forces on the subsystem, and then we will correlate that data with real testing results from the wheel force transducer. The drivers also mentioned that it took significant effort to steer the car during the endurance event. So I will also look into changing the gear ratio to allow for to facilitate easier driving. As for the design presentation, we want to have more component level testing in addition to subsystem level testing. This is the CAD for our current steering system. We have an aluminum housing with brass bushings. So far, the simulations and analysis we've done includes a simple line model or kinematics model. And Sienna, who was steering lead before I was, she did some FEA on the components of the system. Here's the FEA on the gears and on the steering rack. For in the future, we want to have also data from the dynamics model and also have AGMA gear analysis, which is to say that we want to make sure that whatever gear we choose will survive the expected loads without deforming or breaking. The testing that we've done includes steering radius testing at low speed on asphalt, which is to say that we push the car around in the parking lot. Our current steering radius is around 12.4 or 12.5 feet, which is pretty good, but I think we can decrease that by an additional at least 1 or 2 feet. We also did some interference testing to ensure that there was no interference with the suspension or the drivetrain system. We also measured the driver input force using a fish scale. We kind of just put the scale on the steering wheel and see how much force our drivers input when they're turning the wheel. Additionally, we want real on-track testing. We want tire loads data from the wheel force transducer to validate our dynamics model. And we also want to do more testing on different terrains at different speeds in conditions that more closely simulate the conditions that we would undergo in the real competitions. Here are some of the concerns I have about the changes in the steering. I guess my biggest question is we haven't figured out a reliable method to measure the steering radius at high speed. And also, if anyone could provide insight into how the team approached designing the steering in the past, that would be appreciated as well. But we will save the questions for the end. So right now I will pass this over to Gio and he will talk about the brakes.
Hello, I'm Giovanni Marin Cruz, and I'm the brakes PTO for the YGR Racing or Yellow Jacket Racing for 2025 to 2026. For the high-level customer goal, the entire vehicle has the goal of ensuring that we have good serviceability and tunability. That goes the same for my brake subsystem as well, along with the required specifications of all 4 wheels locking up during dynamic and static brake check, maintaining full functionality of the system for braking puts up to 450 foot-pound force, that the brake lines should be clear of interference with suspension and power distribution components such as the half shafts, the A-arms, and including the steering arms as well, along with the fact that the pedal should be able to withstand the maximum braking force of 450 foot-pounds, and the overall system weight should not exceed 11 pounds from the previous years, which it used to weigh 11 pounds. So, for background observations that we had from previous competitions, from Arizona, we had a major issue really with the rear rotor being outside of the frame, which prevented us from participating in S&T, along with the fact that rear brakes had to be cleaned thoroughly to even manage to get some braking force in the rear. Even then, it still wouldn't brake the best at most times. This over the summer and the beginning of the semester, this was fixed by getting a smaller rotor but a much larger caliper piston. Along with that, in Carolina, we had no major issues after that fix. We thought with some small minor issues, just actually of the half shafts having a slight interference by touching the caliper, but this was temporarily fixed by shaving down the bolts. And then along with the fact that we had got mentions from the drivers telling us the brake fade was getting worse throughout the endurance from the hot temperatures and the rotor being too thick to cool down fast enough, and that the rear caliper pads were too rough. So the rotor and the caliper pads themselves got shaved down a bit too quickly compared to what they were previously. For the approach and plan for the brake system this year, there's two like big ideas right now of one having a ergonomics brake jig and then another of manufacturing more of our subsystem in-house. For the brake jig, the idea is either taking the current frame we have that's gonna be cut out of the foot box and making that into a new jig to be able to test the brake subsystem outside of the frame itself, or wait until the spring semester when we create the new modular framing for the footbox where it can be removed from the footbox entirely. So we are allowed to test the values we need outside the frame if it's being worked on by other subsystems. Along with the fact that we also want to do in-house for right now, it's probably going to be brake rotors for the foreseeable future for now because the master cylinder brake calipers take a bit more time and research into developing those. But we want to manufacture our own brake rotor. So we can set our own requirements for the bolts and we can manufacture them whenever we need them. Along with the fact that it improves adaptability. So for the brakes CAD, this is the front assembly that you can see right here with my mouse. The master cylinders, the pedal, the brake lines, and the IS bar, along with the front caliper and rotor for the front wheels, and then the new rear caliper and rotor that we have in the back. For brake simulation analysis, we have what we have completed so far is just the FEA that's applicable for now that with the data we have, such as the brake pedal, the rear caliper mount, and then also we've taken measurements on the pedal travel that we have currently for our current frame setup. And what we do need to work on right now is thermal analysis, specifically this, because this is something that's been getting us for years. And we just need to collect the temperature from the rotor to do this FEA and knock it out. But to do so, we doing this as well gives us more information whether or not the brake fade, how much the rotor heating up is affecting the rotor coefficient of friction, along with the pads as well. For brake testing that we've completed, we've had the previous brake system pressures without the bias for, along with ensuring there's a certain amount of pedal travel to get the amount of pressure we desire. But what is currently needed right now is that we need to redo the pressures for the current rear caliper and the new pedal ratio we have after changing the pedal length, along with temperatures from the rear rotor during dynamic braking to get the temperatures for the thermal analysis, and then measuring the brake pad coefficient to apply it to our MATLAB code to see if that is the discrepancy we are currently facing with the code and the pressures. For the brake highlights and designs and concerns, it's mainly just information. And if you guys have any information at all regarding the manufacturing calipers or manufacturing master cylinders, along with any insight into like what the possibilities would be if we're making a modular footbox frame that we can remove, and if that's like a bad idea at all. So, because that's like pretty brand new. It's a brand new idea right now. So, but yeah.
So yeah, I'll kind of sum up pretty much all the points that we've talked about over the past 30 minutes or so. Again, to start out with, for just suspension, there as a whole, some of the new designs that me, Gio, and Kalen are working on are being designed to prioritize and improve range of motion while reducing the limits of interference, which will aid the implementation of distinct tuning setups. The analyses that we're going to conduct over the next couple of months, and conduct on previous suspension components. Analyses will be conducted on previous suspension components to reveal the effects of fatigue and cyclic loading on parts, and also, of new parts that we're designing. New manufacturing methods will require the verification to ensure repeatable results for any new, designs that we're making that are employing new manufacturing methods. And finally, subsystem testing will provide more direct insight about some of the known load cases that we're going to be using in our finite element models. For steering, one of the highlights is that the steering geometry that's being designed for the new car is going to aim to reduce steering radius while improving driver comfort, so making it easier to steer while making the steering, improving the steering as a whole. And the data we're going to want to collect for steering is similar to that of suspension, but it mainly will assess the impact forces on the subsystem and have a more complete performance profile of the subsystem for more adaptability in the tuning configurations that we have. And finally, for brakes, as Gio said, one of the ideas is to work on a new footbox mounting setup to allow for a full all-up test of the brakes outside of the car prior to the car being sold, obviously. Along with the possible design of custom rotors and calipers. And also we want thinking about the in-house manufacturing challenges that might come with designing and making our own custom rotors. And there's also some area for improvement of the current MATLAB model that we have of the brakes system. So yeah, that's kind of the summary of the suspension, the steering, and the brakes that we've kind of been talking about. And I'd like to open it up. I know there's only a couple people here, but I'd like to open up to any questions that you have about any of the three subsystems. I know that was kind of a lot of information, so I apologize. But yeah, yeah. Okay.
Hey guys, can you hear me all right?
I cannot hear you, Chaz.
Oh, really?
One sec.
Can you hear me now?
Chaz, I can't hear you. I don't know if you're trying to talk.
We can hear you. I think it's just they can't.
Okay, this is all right.
Audio off my computer.
Yeah, sure. You're on the
Oh, so
okay.
the
We're gonna-
thing can
okay.
hear me?
Yeah. Can you?
Yeah, so I'll unmute my computer.
I'll mute mine.
and- Maybe to- Unmute your mic too. Microphone check.
Yeah.
Can you guys
Yep.
hear us? Okay.
Awesome. Cool.
Sweet. All right, can you hear me now?
Yep.
Awesome. Yeah, for starters, awesome presentation. The last, especially the overall and the frame, have been great so far. So you guys adding right on to it, Miles, Lynn, and Gio. Really appreciate it. Obviously, very well prepared, awesome images, good recs and specs. I like tying it. You guys tie it all back to competition, which is great. And what the judges are doing. So let me see. I feel bad. I was never a suspension guy on the team, but but I remember a few things from competition. Let's see here. Go in order with you, Miles. What were some of the questions you had at the end of your presentation?
Yeah, so for me, first off, I had a couple I would talk about fatigue analysis. I know we've kind of brought up fatigue analysis over the past couple the last two PDRs. But really I want to know, or yeah, I guess I'm looking at the screen too, but yeah. Firstly, let's find it. There we go. I kind of wanted to just know, like, was in your time, was there any possible prospect of there being a non-CNC aluminum upright design, or was that kind of just assumed to be, the design for, the entire duration that you did Baja?
For my time, the closest we got was obviously the first Genesee, and I think you were around for that, where they just had that aluminum adapter.
Yeah.
Which I guess was just turned, I don't know if we CNC'd that actually. We'd have
You're
to
talking
double
about
check.
the trailing arm, yeah?
Yeah,
Yeah.
the trailing. Yeah, I'm not considering the fronts.
Yeah.
Yeah, I would look at with you weighing this back and forth, the difference is now you guys definitely have built up a welding team. So it might be different than when we were doing it, just having one or two welders. So I guess I would just consider as time, time is an expensive aspect, obviously. The aluminum and the CNC, might be expensive. Definitely, you can factor in professors in your time in the spring, obviously. Gets tight as well. So there's all those factors. But definitely would be a lot of welds there. So I can see both ways. I definitely like the fixture, that fixture similar to what we were doing with that rear trailing arm. So those were always great.
Yeah, I mean the fixturing process for that for the welded upright specifically is gonna have to be very kind of well thought out. There's upwards 8, 9, or 10 different welded tabs that kind of all go onto the same steel ring that we have, and the idea right now is that we would have some sort of complicated fixture that has some elements of precision fixturing in it, and like locating basically a bunch of locating features for all the different tabs, to ensure as high accuracy as we can get. But the idea would be we would measure that before welding and then weld it and then measure after welding too to get an idea of what kind of deformations we see from welding. And I can't think of any other ways we would want to actually test the repeatability of the manufacturing, apart from like using the ferro arm. Because in reality, like if it ends up being that like we can't like repeatedly make these robot like consistently, then there's not going to be much of an argument for fully switching the team to use welded uprights like this. So
Is that image there of like a front upright?
that's a front upright, yeah. So that's with
Okay.
the steering link and the mounting points for the two A-arms, and that actually we're in the process of making that right now, because it's just kind of a prototype that we're throwing together with material that was probably actually used from when the trailing arm was still a steel upright and or just a fully steel assembly. But yeah, that's our current design basically or possible design for the new uprights.
Do the welders have any comments for how long a part like that would take?
Yeah, so there's a discussion that is to be had with welders about this, and most of it's actually bent. So a lot of it is just bent sheet metal, and while there are a lot of intricate small welds that need to be made, there hasn't been an explicit negative reaction to the amount of welds that need to happen. Like it's going to be possible, but it's still like a big question is like how much it's going to warp and how much that's going to affect the positional tolerance of all of the welds.
Yeah.
So
I
right
agree.
now we
That's
think it's
probably your
possible
biggest
given the
concern.
capabilities of it.
Yeah, I agree. That's probably your biggest concern. Do
Yeah.
you have any interface between the steel and the bearing, or would you do to aluminum again, or
Well,
what do
we
you
were thinking, so it should be sort of two stages. First, the central ring, we could pump out a bunch of those on like the Haas, or even manually, kind of like the old trailing arm aluminum inserts were made.
Yep.
But that would then be welded, and then
Mhm.
depending on the results of the weld testing that we do to see how much the actual deformation happens of like that inner bore, because the bore needs to be accurate to a couple 10,000ths of an inch to be effective. We could take the upright and then turn it again, or put it back in the mill to clean up the inside to make it suitable for the bearing. So that's one of the main concerns that we have right now. And I know that was tried a couple of years ago, basically this design. But it really depends on kind of how much heat actually goes into it from the rolling process. So that's something we're trying to learn about right now.
Yeah, I'm trying to think if there was any big problems with that
Yeah.
trailing arm. I know my year, I kind of know our endurance. We just didn't have enough spares with that one, but I forget the year after how you guys did with that. Or I guess my question, the current rear trailing arm, I like how you had a slide on that because I didn't know you guys did that. That looks pretty cool. Do you guys like that?
What? Sorry. Okay. Yeah. So that's one of the design choices I made last year doing rear suspension. Because we had a bunch of problems with kind of not having enough spares, and the trailing arm as a whole being a really complicated welded structure. So yeah, the reason we made that change was because of there being problems with the welding process that we had for making the old trailing arm. So
Nice. Are you keeping that for this year then?
Chances are yes, given the time that we have. But my thinking would be that if we can get the front uprights to work with a steel configuration, the possibility of opening that up to also be used for the rear would be quite useful, because that would put the manufacturing of both the front and the rear, the front uprights and the rear trailing arm assembly, like kind of in parallel. and make manufacturing as a whole a lot easier. So if we could use that same ring, so the ring here, the ring seen in the upright, if you could use that both for the trailing arm and for the uprights,
Yeah,
you
it's
could
just a
decrease the
tad.
manufacturing time a lot. So
Is there any issues with the current design that you saw in competition, or?
So in competition in May, the first competition that this car went to, the trailing arm had some basically a buckling failure. Because the shock is now not, I mean, obviously the shock's not mounted on the upright anymore. It's mounted just
Yeah.
on the tube itself. And that was
Mhm.
causing us some problems, but the first iterations we had of this were made of like a square tubing 1018 stock material. And over the summer, like I mean, we tried different geometries, we tried different like thicknesses, and we tried different ways to gusset everything, but the 1018 did not end up being strong enough in any case with this geometry. So we switched it to at the beginning of this school year. So in like around August, September, we changed it to be a 4130 trailing arm, and that ended up being perfect. Like we didn't have any problems with that from the South Carolina competition. So right now there's no, inherent problems with robustness of this trailing arm, but it's also quite heavy. So there's definitely an opportunity for optimization, which would require some change in the kinematics of it. But if we decide to pursue those changes in kinematics, that would open the door to also like bringing this back to steel, upright, and welding kind of discussion. It opened the door to using the same technology we have for the front uprights as steel and applying that to the rear. So
That's tube, right?
the tube.
4130.
Yeah,
Like what thickness is that?
it's 083.
Okay.
Yeah.
That's still not too bad.
It's really it's smaller than, or I mean it's thicker though, so it's a little
Yeah.
larger in diameter than previous trailing arm models. So
Yeah. As you've probably seen on other teams, I know they've done a lot of you could similarly they kind of do like these box beams or kind of like these the square tubing, like the sheet metal in the direction of your load, and they're able to cut out some weight savings holes. You could
so
look at
that kind of idea was we would have pursued that, but with the use of the modular uprights, we didn't want to change the uprights between the two competitions we had this year. So we ended up constraining the design or redesign of the trailing arm for the second competition we had to being compatible with the uprights, and that kind of closed the door to the box style trailing arm that you just mentioned. But that
I'm
definitely,
I'm just brainstorming. If you got something that works, like I wouldn't touch this. I would focus on the fronts, like you were saying. So
no, but that's definitely considered. And we that's definitely somewhere we might take this design in the future.
But that's cool. Yeah, I guess it sounds like you guys are working on this front. So I guess keep track of how long it takes to weld up, obviously, and kind of make a decision from there. If that system also helps in your interferences as well, that's a huge plus. If you're able to, as you were mentioning, that was kind of your limiting factor. So I'd look at it from that standpoint as well.
Yeah. I mean, specifically the interference, like right now, the rear shock is like fully extended basically at ride height. So that's one of the main one of the like another reason to change the kinematics of the rear suspension is because we're kind of limited right now in ride height. So it's possible we might shift the shock to being mounted on the firewall. I don't know if that was considered in the past at all. I've seen some teams do like shock or firewall mounted shocks, but we were a little bit concerned about the increased load that we'd see from mounting the shock on the firewall last year, so that's why we kind of stayed away from it and accepted the lower ride height that we get from the current geometry. But that's another design decision or choice that we're kind of like processing right now. So yeah, that kind of covers it for me. Gio or Kaylin, do you have any specific things you want to talk about right now? Or Chaz, do you have any questions for Gio or Kaylin?
Yeah, no, absolutely. I'm trying to see what I got written down here. I guess kind of just the main concerns you got. Each of you mentioned the questions you had for steering. I guess for steering, won't like my answers. I'm not a suspension guy, so you'll have to get the nitty-gritty stuff from hopefully some other alumni are able to help. But in my opinion, what I've seen, we've always struggled with steering. So I had a few questions about the rack and pinions stuff you were looking at. Are you still able to just purchase online? Are you looking to are you able to basically are you able to find what you need online, or do you have to do anything custom with the steering rack and pinion?
We buy our gears from McMaster, but everything else, we manufacture in-house. The housing we make with the house machine, and everything else is, yeah, we hand machine everything else.
Yep. No, if you're able to get, if you're able to purchase something online, I think that's perfect for now. I just want to make sure I always remember having trouble finding what we kind of needed. In the one design or one image, was there two pinions on a rack? Yeah.
Yeah, there are two gears.
Okay.
Since we moved the rack to be under the gear instead of above it,
Yep.
we have to add a middle gear so that the steering wouldn't be
Yeah,
so
back
that
and
one.
gotta make sense. Ergonomically, that looks a bit better. That's good. Sweet. Yeah, the steering you were mentioning about high speed turning, it's a good question. Similarly where you've done with image processing, I'm sure there's a few options. Trying to think off the top of my head, I'm thinking of, if you have like a grid or something on the ground and you're able to do high, because I agree, you can definitely steer differently at high speed than lower speed, especially with and I'll wait to hear from Drivetrain tomorrow, but if they still have that direct, and you can thank me from that for that, just the direct drive in the back, it definitely hurts steering in some cases. Surprisingly, Quattro, for how heavy and big it was, is actually pretty good maneuverability that year. Just based on how the suspension was set up and that the track width wasn't too wide. We didn't have a lot of other things we liked on it, but we were able to kind of swing it around. So my main advice for steering, I guess, is you can design really good steering, but if no one has time to actually run the car in the spring, they'll probably mess up maneuver anyway. So just like with anything, getting the cars done as early as possible. But for all the technical stuff, I'll need to defer to some of my other alumni. I didn't do much with this.
Yeah, we're working on finishing the designs, finalizing the designs earlier this year so that we have more time for actually manufacturing and testing.
Nice.
Do you have any other questions?
I don't know if there's anything else you have for me. Again, like I said, my background wasn't in suspension, but yeah, feel bad I can't can't advise too much.
Do you know what kind of steering Quattro ran? Was it like Ackerman or Parallel or anti-Ackerman?
Oh, I always mix them all up. I think it was one of the Ackermans, but yeah, there was a lot of funky things with that too. We also for that one we also had the differential in the rear, which would let the differential wheels also turn at different rates. So I know that was the only bonus to that setup. Versus my drivetrain was more lightweight, and I was thinking more about quick turning, where you kind of skid, and had more of that maneuverability. Um, so I'm trying to think. The main thing with Quattro I remember was I think the track width wasn't that wide either, but you were still able to turn pretty sharply. Um, but yeah, that was a heavy car.
Okay, thank you.
Yeah.
I might be able to dig up something on if we have
That'd be
that
great.
point.
Do you have any questions, Chaz? Or Chaz, do you have any questions for Gio?
Yeah, I think you're looking at all the right things for the brakes. I remember those MATLAB, yeah, having that issue our year. I didn't know if there was any more work done on that. This has always been a little tricky. All right, so you got two master cylinders. All right, did we have one before? I forget.
They did have, well, they had two master cylinders, but it was in one tube itself.
Yeah.
So
Got it. Yeah, we just did that a different year. Walter Cruz is the alumni. You can talk about
yeah,
that.
I talked to him before. And it's like blown up like 2 times. So.
Yeah.
Oh yeah, it blew up on the first competition. So yeah, I don't know why we switched that up. Again, I overall I like your presentations because you guys are, as Professor Muir would say, telling a really good story, and focusing on competition, versus sometimes in the past we've just wanted to try things. So it's really good. Yeah, we ran double cylinder for almost all the time I was here until then. So that makes sense.
Mhm.
And then behind the rotors, you mentioned the main reason you guys want to try and manufacture some are just for the bolts and
Yeah,
what
they're
was the other reason?
they're non-standard bolts, and also just to like be less reliant on things we have to buy purchase because they also don't make these rotors anymore, and like
Mm-hmm.
they're like best rotors I could find online. So making them in house will just make it our life easier to just have them our own. And I have different designs as well, so we have weight savings as well.
Okay. Are you able to I think Bill's mentioned it before. Are you guys able to grind them down in house? I forget what the
Yeah.
process is called. Okay. Okay. Yeah, as long as Bill's there, yeah, it should be
Yeah.
pretty
I don't think
simple.
we've tried.
They-
I don't know. I don't know if you or if anybody tried, making brick rotors in your time, but we haven't tried grinding brick rotors down, but we've been told by Bill that it would be possible. So
Sweet. Yeah, I think that was the same state we were in. I think we wanted to try,
we want to try, but yeah.
and we probably just ran out of time.
Yeah.
But yeah, there's definitely benefits, especially if you didn't need, you could change up your diameters, but
Yeah.
probably still need them. Yeah, and what you get, like, if you get those just laser cut at Paragon or something, they should be pretty close.
Yeah.
So then Bill can just, if you guys are able to grind them.
Yeah.
Sweet.
Yeah.
Yeah, it's all good stuff. Yeah, the ergonomics with the brake pedal's always been tough. I always had trouble wrapping my head around that one.
Yeah. We've been making, I mean, this last year we've kind of really tried to make the foot box the foot box.
Yeah.
Which is I think we've accomplished. But
Nice.
there's still some room for improvement. So yeah.
Nice.
Yeah.
What's the track width you're going again for the
So the
wheels?
track width is like it's at a maximum in the front right now. So it's a little bit different for the front and the rear. So the front is 64, in the rear, at least on the current car, is 60. So
Okay.
if we can, I mean, the wheelbase, if we can move the wheelbase forward a little bit, we like just with basic, hand calculations, you can decrease the steering radius by like around a foot, depending on, the actual magnitude of how far you move the wheelbase, or decrease the wheelbase. But, yeah, right now the track width is at the maximum in the front and it's close to the maximum in the rear. But there's some discrepancy between the two.
Okay. So I see. Okay. Yeah, like previously with the Hilliard differential was that limiting suspension where they couldn't bring it forward enough. Okay.
Yeah.
All right, so because I was never great with suspension, but I remember we had cars with, it doesn't, you can have a pretty wide track width, but we still had good steering.
So what was the track width of Quattro? Was that like, similar around the maximum of what was allowable, or you said it was a little thinner?
In my head, it seems less wide, but maybe it's just because the rest of the car was so. I got it. Like, yeah. I don't let me talk too much on it. I'll try and see if I can dig up a report or something, or maybe talk to if Lale was the official suspension on that one, or it was really like Jafar's suspension back in the day. Because that's the only thing I remember. I remember us, if Bruno was here, he did maneuver pretty good in that. Maybe it was just his driving, or maybe the course was easy at Rochester, but I remember him doing good on that, and that was a heavy car.
Yeah, the two maneuver courses we've seen this year have been pretty tough. Only like a handful of teams have completed them. You know, out of the total population teams that have been in competition. But
Yeah, they're
we're not-
tight.
we're-
That's
yeah.
the only thing about the track width is I feel like they set it almost at the track width. That's the only
Yeah.
thing I'm thinking.
Mhm, yeah.
You know, what's the benefit to, if you have that wide track width, are you able to get, you're able to get the plunge where you need or
Mhm.
like,
Or do you get more steering from like? Do you get the
Mm.
increased steering you need from having a large track width? Yeah.
okay.
Yeah.
Hmm.
So yeah. So yeah, that's all we have. If those are all kind of the questions you have for us, I think we kind of call it there. I assume anybody else in the meeting doesn't have any questions. Con, anybody else? Sorry, second to last slide. Yeah.
So can you explain what you're talking about with the
Measuring.
Like finding it out.
yeah, you're trying to find it out.
Yeah, because we still like don't know that for sure. Like, we have like an estimate of what it could be from like calculation wise, but like we need to like actually verify what it is to put it in because it's probably what the issue is with the
So you can calipers, right?
Huh?
So you can build with calipers, right?
Yeah.
Good to find graphs with that function, which will just help you out.
Yeah, but that one measured component we think is what is
the issue.
causing
Nothing
the
else, right?
what?
Nothing else, right? Except,
There's reason to it not necessarily. Yeah. So yeah, the measuring that will probably significantly improve the accuracy of the model.
Yeah.
So yes. All right. If that's it, then I think we're gonna call it there. Thank you so much, Chaz and everybody who came. It's always super helpful to have these design reviews, just to talk through our designs and get feedback from what the team's done in the past and any engineering advice that you have on what we're doing. So yeah. Thank you for coming. And the next PDR, I think the next PDR is Drive Train tomorrow at 8 p.m. Followed by Ergo on Thursday, 7 p.m. So yes. Thank you for your time, and have a good night.
Great job.